Hi students, welcome all. In this module we are going to discuss about cross product. Let A vector and B vector be two non-zero vectors, then the product A cross B, A vector cross B vector in that order is defined as a vector. A cross B is a vector whose magnitude is mod A mod B sin theta, that is A cross B is equal to mod A mod B sin theta is in n cap, where n cap is the unit vector perpendicular to the plane containing A vector and B vector. There is A vector and B vector are two vectors in a plane. Then A cross B is a vector is perpendicular to the plane containing A vector and B vector. Okay. Now let us discuss some properties of cross product. Properties. First property is vector product is not commutative, that is A cross B is not equal to B cross A, but A cross B is equal to minus of B cross A. And second property is M A vector cross B vector is equal to M times A cross B, which is equal to A cross M B vector. Number 3, A cross B plus C is equal to A cross B plus A cross C. Number 4, A cross A vector is always equal to 0. Next property number 5, A cross B equal to 0 if and only if A vector is, if A dot B is equal to 0, then A vector is perpendicular to B vector. Here A cross B is equal to 0, A vector is parallel to B vector, where A vector and B vector are, where A vector and B vector are non-zero vectors. Next property number 6, we know that I cross I, J cross J, K cross K all are equal to 0, and I cross J is equal to IJK, I cross J is K, IJK, J cross K is I, and K cross I is equal to J. Property number 7, if A vector equals A1I plus A2J plus A3K and another vector B vector is equal to B1I plus B2J plus B3K, then A cross B is equal to determinant. First row is IJK, the second row is A1 B1 C1, sorry A1 A2, A vector is A1 A2 A3, then we write the second row as A1 A2 A3, third row is B1 B2 B3, then A cross B is equal to IJK A1 A2 A3 and B1, then I into A2 B3 minus A3 B2 minus J into, expanding along first row we get A1 B3 minus A3 B1 plus K into A1 B2 minus A2 B1. Property number 8, if A vector and B vector are the adjacent sides of a parallelogram, then the area of parallelogram is equal to modulus of A cross B. It is in a parallelogram the adjacent sides are represented by two vectors which are A vector and B vector. A vector and B vector are adjacent sides, then the area is equal to modulus A cross B. If A vector and B vector are the diagonals of a parallelogram. Then the area of parallelogram, then the area will be is equal to half modulus A cross B. If the A vector and B vector represents two diagonals, this is A vector, the another one is B vector. If A vector and B vector are diagonals of a parallelogram, then its area is half modulus A cross B. Okay. Number 10. A vector, a unit vector perpendicular to a plane containing A vector and B vector is given by a cap. N cap is equal to is given by unit vector perpendicular to a plane containing A vector and B vector is given by n cap is equal to A cross B by a vector perpendicular to a plane containing A vector and B vector is A cross B. A unit vector perpendicular to a plane containing A vector and B vector is A cross B divided by modulus of A cross B. Next, we know that A cross B whole square is equal to A square plus B square, that is mod A square mod B square minus A dot B whole square. Next, property number 12. A vector perpendicular to a plane containing A vector and B vector is simply it is A cross B. If it is a unit vector, then we divide by its magnitude, or a vector perpendicular to a plane containing A vector and B vector is A cross B. Okay, we will discuss some problems on vector cross product in our next module. Okay, thank you students, thank you all.